In the heart of a Wisconsin winter, 3 University of Wisconsin Eau Claire students, Danny Raymond, Grace McDonald and Ella Ostreicher, set out for the tropical coasts of northern Samar, Philippines. Their mission, a 3-week scientific expedition to study one of the world's most dynamic coastlines. Guided by Dr. Harry Joel, their research would focus on Gamay, a community living at the mercy of the Pacific's power. Here, typhoons and shifting seas shape daily life, and the students arrived with advanced technology to uncover the coastline's hidden stories. Thanks to the International Fellows Program, their journey was fully funded, allowing them to immerse themselves in research and culture. This wasn't just an academic trip, it was a chance to test classroom theories against the raw reality of the field. The students would learn about geology, weather, and the resilience required to live on a changing planet. Their work aimed to connect distant communities through shared environmental challenges. For Danny, Grace, and Ella, this was more than research. It was an adventure into the unknown. Their journey marked the start of a project with the power to bridge continents and inspire global solutions. The team's central question: how do coastlines respond to both sudden storms and slow, relentless change? In Gamay's vulnerable coastal plains, every storm leaves its mark, layering sand and sediment into a geological record. By studying these layers, the students hope to reconstruct centuries of shoreline evolution. Using technology, they looked beneath the surface, reading each stratum as a chapter in the coastline story. This detective work is vital for predicting future risks in an era of rising seas. Their goal: to reveal the hidden architecture of the coast and identify the signatures of past typhoons. Understanding these patterns isn't just academic, it's crucial for the safety of communities living on the edge. The knowledge gained could help shape disaster preparedness and resilience. In Gamay, the past and future of the shoreline are written in the sand, waiting to be uncovered. To unlock the secrets beneath the sand, the team used ground-penetrating radar, or GPR. This technology sends radio waves into the earth, capturing echoes from buried layers and objects. As the GPR sled glided across the beach, it created radargrams, images revealing the subsurface's hidden structure. Uniform bands signaled calm periods, chaotic patterns pointed to violent storms. The students learned to interpret these clues, translating abstract lines into stories of past events. GPR revolutionized their research, allowing rapid, non-invasive mapping of the coastline's history. Before GPR, such insights required laborious digging. Now, entire landscapes could be scanned efficiently. Dr. Joel and his students identified ancient beaches, river channels, and storm deposits, all without disturbing the ground. This technology gave them a powerful lens to see the invisible forces shaping the coast. With each scan, the team pieced together the dynamic history of Gamay's shoreline. The lessons from the Philippines echo across the United States, where hurricanes threaten Atlantic and Gulf coast. The physics of storm impacts are universal. High winds, surges, and erosion endanger communities everywhere. Dr. Joel emphasized that understanding past coastal responses is key to disaster preparedness. By studying the active shores of the Philippines, researchers gain insights that apply directly to U.S. coastlines. Geological signatures of past super typhoons in Gamay help identify vulnerable areas back home. This knowledge informs smarter development, resilient infrastructure, and effective evacuation planning. The students' work feeds into global models that predict coastal change and risk. Their research is part of a worldwide effort to save lives and protect property by learning from nature's history. The data gathered in Gamay could help shape policies from Florida to the Carolinas. In a world of rising seas, these shared lessons are more urgent than ever. This project thrived on international collaboration. The UW-Eau Claire team joined forces with Singapore's Nanyang Technological University and Filipino scientists from the University of the Philippines and Mindanao State University. Each group brought unique strengths: GPR expertise from the Americans, advanced modeling from Singapore, and deep local knowledge from the Filipinos. Together, they navigated the region's challenges, sharing data and insights in real time. The students learned technical skills, cultural context, and the value of teamwork across borders. This fusion of perspectives created a research environment far richer than any single team could achieve. The project showed that global challenges demand global solutions. For the students, it was a lesson in the power of international science and the importance of working together. Their experience proved that collaboration is the future of research on a changing planet. In Game, science became a bridge connecting continents and cultures. Field research rarely goes as planned. The team's carefully chosen sites, mapped from afar, often proved inaccessible on arrival, blocked by dense vegetation or storm debris. These setbacks demanded quick thinking and adaptability. The students learned that in the field, flexibility is as important as preparation. With guidance from their Filipino colleagues, they found alternative locations and adjusted their research on the fly. These challenges became invaluable lessons in problem solving and resilience. Science in the wild is about navigating uncertainty, not just collecting perfect data. The experience taught the students to think on their feet and trust their team. Every obstacle deepened their engagement with the landscape and each other. In the unpredictable world of fieldwork, adaptability became their greatest asset. When plans fell apart, the team's adaptability shone. Rapid collaborative problem-solving replaced rigid schedules. Filipino partners offered local insights, helping the group find new, sometimes better, research sites. These unexpected changes often led to surprising discoveries. Sometimes the best data came from unplanned locations. The students learned to see challenges as opportunities, not failures. This process built confidence and strengthened international bonds. They became active partners in a dynamic investigation, adapting methods to the landscape. The skills gained, critical thinking, teamwork, resilience, will serve them for life. On the Philippine coast, flexibility proved as valuable as any scientific tool. The ultimate goal of the research was real-world impact. Grace McDonald hoped their findings would inform policy and protect vulnerable communities. GPR data could help create hazard maps, guiding smarter zoning and resilient building standards. This proactive approach, grounded in geological history, is far more effective than reacting to disaster. The research also guides investment in coastal defenses, seawalls, beach nourishment, or mangrove restoration. Their findings will be shared at conferences and with government agencies in both the Philippines and the U.S. Through this process, science shapes public policy and saves lives. The journey from fieldwork to legislation begins with projects like this. The UW-Eau Claire expedition stands as a testament to the power of international research. Global challenges, climate change, rising seas, stronger storms, demand global cooperation. By working across cultures and disciplines, the team found solutions stronger than any one group could achieve. The students gained not just technical skills but a sense of global citizenship and empathy. Hands-on, international research transforms education, preparing the next generation of problem solvers. Institutions like UW-Eau Claire invest in a sustainable future by supporting these experiences. This project connected past and future, the Philippines and the U.S., and people across continents. As the team looked out over the Philippine coast, they saw not just a shoreline, but a shared horizon. Their story is a call to work together for a safer, more resilient world.